Welcome to Shelley Physics episode on emission spectra and atomic structure. What we're going to look at in this episode is how the electron structure of an atom can be actually seen by the light, the type of light that the atom emits when it's electrically excited, put into an excited state. Today we're going to be using a high voltage source and tubes of gases, the various gases, so that you can see these emission spectra. But in order to analyze and look at the colors that are given off, we're going to need to use a particular device called a diffraction grating. And I have a couple of them in these awesome wicked glasses. And the nature of our light usage today is why I have the lights out right now and my trusty flashlight going on right here. So anyway, in these lenses, these diffraction lenses, if I hold this up, you might notice everything is a little bit blurry. But now if I give a point of light on the other side, you can see through the diffraction glasses that there's a rainbow of colors. This white light that I have here is being broken up into a lot of different colors. Now heat does that. When you heat up objects, when you heat up things, they first grow like orange hot and then red hot, and then they might go to white hot. Sometimes they even have a bluish glow to them. But that white hot comes from a concept called black body radiation, and that's a topic for another time. Point is, when things get hot, they glow, and they'll start to emit first low frequency light and then higher frequency light, which transitions from red colors as we see them, and yellows and greens and blues and indigos and violets, as Roy G. Bibbs. Oh, I forgot orange in there. Don't forget orange. That's where we get the whole spectrum from these glasses, breaking up the light from this one single source. You get that rainbow effect coming on. And you can also see that there's a structure to the diffraction grating glasses that sends that light in certain directions. All right, so now what we're going to do is I'm going to show you my lab setup here. This is the high voltage source I'm going to be using. It says danger high voltage, you know to stay away. And I'm going to have to hold the glasses up here, so it's going to be a little awkward. But once I turn this on, you won't see me anymore, and you will see the wonderful glow. So this first tube I'm going to be using is something you might recognize from a sign. And I will have to work with the lighting levels a little bit. So it is an orangish kind of a glow. You can see my shirt glowing here. Nice orange color. And if you guessed it, this is neon. This is a neon gas. And looking under the diffraction glasses, you'll notice a pattern. Now I do need to adjust the color here because I want to make sure that you see what is actually seen with the eye, because these computer filters, they mess with the colors a bit. So that's pretty close to the color we're going for here. It's you're seeing more of a magenta, but what you really see would be a red, an orange, and a yellow color. And those go together to make this nice vibrant orange color from the neon that we're used to seeing in neon lights. My next one, though, this next one is the most simple of atoms, hydrogen gas. Now my tube has been having some problems, so I might have to adjust a little bit. All right, and to adjust the color a bit, get a little bit more vibrancy out of it. We should be seeing a kind of a pink purplish glow. This is coming out more blue. This is hydrogen under the tube. You'll notice it's not as vibrant. However, we are going to be seeing some very specific colors. Now you might see a lot of colors in there, some of them very dim, some a little bit brighter. In this, there is a definite red color. If you see a strong magenta, it's really a red. And then there's a turquoise kind of a color. Very specific colors are what's coming out here to make this type of glow that we see all together. When those colors add up, they produce something that's a combination of all the colors. It's called a wave interference there. They're interfering and adding up. There is one more color that I can see through these glasses that might come in a little bit maybe difficult for you to see, but there is a nice definite indigo or a deep blue, and it's not really showing up too well in my lens here. But the main thing is you can definitely see a breaking up pattern of these colors. See if I can bring that out a little bit more here. That blue. It's hard to get. It's past that turquoise. All right. But definitely right there you see the turquoise, and a little bit lower is a nice bright, magenta, and a little bit lower than that is a nice turquoise. So that is the hydrogen. And my final tube I'm going to show you is the next simplest atom. Besides hydrogen, what's the next one on the periodic table? Hopefully you can get this one. It is helium. So this last one is helium. This one should be a nice color for you. All right, so this one is a yellow. Let me try to bring out that yellow color. There we go. It's a beautiful yellow color. Depending on your computer screen, you may or may not be seeing that very well. It's kind of a creamy looking yellow. We look underneath these glasses, and sure enough, do you see that? You see that strong yellow color come out? It's very prominent. Okay, so we get that yellow color. But also, look to see what accompanies it. Do you see the turquoise? Do you see that magenta, which is really a red? Okay, right in the middle of the screen, you can kind of see a magenta, then a yellow, then turquoise, and oh, look at that, it's a blue. It's a blue color. So if you think about those colors that we're seeing here, and the colors that we were seeing with the hydrogen gas, there are three that are very common. It's that magenta or red color, then the turquoise, and the dark blue. This one has it also. Helium has it, just like hydrogen did. But helium has a new color there that hydrogen didn't. It's got that yellow. So what are we seeing here? We're seeing a similarity between the emissions that are produced by helium and hydrogen, the simplest of all the atoms. So what about their atomic structure, the electron structure of these elements? When you go and look and investigate the electron structure of atoms, if you make a Bohr model of hydrogen and helium, you'll notice that they have very similar structures. Hydrogen has one electron, and it's generally in its ground state in that 1s energy level. Helium also has electrons in the 1s energy level, and that's it, but it's got 2 electrons. So what you're going to see happen is when this high voltage source is applied to the atom, to a hydrogen or helium atom, it's going to excite those electrons. They're going to bump up to a higher energy level, but they don't stay there. It's kind of like if you take a ball and you roll it up a hill. It goes up and up and up, but it gets slower and slower and slower, and then reaches a maximum height, depending on how much energy you put into it. It rolls up to the top of the hill, but it doesn't just stay there. It rolls back down, and that energy turns back from a potential energy to kinetic energy. If you ever studied that, that energy goes from a potential state to a more motion or kinetic state. Likewise, electrons are energized by that electric field, and they bump up, they gain some energy within the atom, and they don't stay in that state. They're going to fall back down. Those electrons will fall back down to their original resting state. So when they do that, they release that energy in the form of light. Now, because the atom and the electrons are quantized in energy, they have very specific energy levels that they occupy. You know, you can take that ball on a hill and roll it up a little, or roll it up a medium amount, or roll up a lot. There's an infinitesimally small number of tiny increments that are infinite number. I'll just say that again. An infinite number of increments of energy levels that a ball rolling up a hill can have. But electrons only fill certain specific energy states. Those energy states are quantized, and that's where we get like quantum theory and quantum mechanics from. So what we're seeing here is very specific colors of light that are produced by these tubes. That's indicating that there's a structure to the atom, and we can see that structure. Electrons may jump up from that first energy level, up to one of the sub-levels in the second energy level, but when they fall back down to that first energy state, they're going to emit a very specific color of light that corresponds to that however much energy they had gained by that electric field. And so we are actually seeing the structure of atoms when we see these emission spectra.